Ladies and gentlemen, welcome to today's web seminar. My name is Mike Perkowski with TechTarget. I'll be your host and moderator today. We appreciate your taking time out of your busy day to learn more about this topic, managing your data in a cloud-native landscape. Before we go any further, I do want to take a moment to acknowledge and thank our sponsors for today's program, Red Hat and Couchbase. We appreciate their support. Today's speaker lineup has three very experienced speakers who are going to be covering our topic today. First, we'll hear from Aaron Goldberg. Aaron is CEO and founder of Content for IT. Aaron is a longtime industry analyst who has covered the industry from a hardware, software, and services perspective over many years. Secondly, we will have Vijay Arungaruki, who is the Senior Solutions Architect for ISV and Embedded Partners at Red Hat. And third, we're going to hear from Evan Peace, Principal Architect at Couchbase. So let's get started. I'm going to turn the program over to our first presenter, and that's Aaron Goldberg. Aaron, the floor is now yours.
Thank you very much, Mike. And I'm thrilled to be here today talking about a topic that everyone needs to be aware of. And that's, as we move forward in a digitally transformed world, it's very clear that we need next generation software infrastructure. The things we're doing today are very different than the things we used to do in the past. And there's really 5 key ways that we need to look at this change and the new demands for software going forward. First is that native support for the cloud is non-negotiable. The reality is that cloud infrastructure has become the way things are done, whether it's hybrid, public clouds. It doesn't matter. But the reality is, if you have to change or tweak or the software is not set up to support the dynamism of the cloud, it's going to be nothing but trouble going forward. Second, portability matters. The whole notion of a software-defined data center, that we can really have true fluidity of workloads, that we can use any resource, that we have resource pools that truly are pools, not segmented into deep end and shallow end or this environment or that environment, is so important. And portability is key because it lets us not only create efficiencies for IT, but it lets us ensure service levels, gives us the flexibility we need. Third, we have to empower DevOps. Development is a very different world than the old days of COBOL programming, if you're not the state of New Jersey. And we need to make sure we've got a platform and infrastructure that lets us get the most out of our DevOps resources and really empowers them to do the great work they can do. Fourth, and it's really an important one, as we're doing so much more and so much more is going on, automation is essential. That there's just not enough way to throw bodies in a timely fashion at the problem anymore. IT moves too fast, and automation is the only way to keep up the speed that's necessary in the next generation. And lastly, and very importantly, is true scalability. In the past, we really focused on scaling up or scaling out. That was, can we do that? Can we meet big demands or spikes or peaks? The reality is that we need to scale both up and down, because wasting resources, not turning off resource hogs or not being able to reuse resources is really not going to make it in the long term. Let's start with looking at the support for multi-year hybrid cloud. As I said, that's a non-negotiable. Cloud is the way things are done. And most importantly, we want a software infrastructure that has that seamless portability. We can't make it a problem with the administrator. The administrators just can't intervene. A, there's too much mobility, too much dynamism, and B, it just takes too long if humans have to be involved. And the proof of this is a recent Symantec survey that actually might be a stunning finding for a lot of people, that an average enterprise uses more than 900 different cloud services. Now, a lot of those are SaaS, and that's absolutely true. But we're finding that, it's not unusual to have 7 or 8 or more cloud platforms that are being used to run workloads. And many of them are very different, and many have unique capabilities that we want to take advantage of. And some are just kind of standard run-of-the-mill resource. But we need to have that flexibility to move things as necessary. And as part of that, we have to have development become cloud native. We want to use the tools such as containers that really were designed for the cloud environment. And containers are going to have a central place in things. VMs were kind of the last decade. Containers really are kind of the new, more modern way to get some of this flexibility, to support the dynamism, and to really give DevOps kind of a better approach to a lot of the workloads that are being created now. I'm really bullish on containers because I can think containers were really a brilliant creation, frankly, of meeting what the outcomes needed to be with a process that really could be supported by the development talent and that aligned with it well. We start at the top and work our way around clockwise. The most obvious, we want to save money. Infrastructure efficiency improves while we use containers. But portability may be one of the key benefits. You keep hearing me say this word portability, flexibility, agility. One of the hallmarks of digital transformation in a transformed company, when I talk to CIOs, is it's all about agility and portability. Give me options, give me flexibility. Any siloed environment is by nature a problem waiting to happen. We also need developer productivity. And productivity in a lot of aspects. We want things done faster. We want them to be done more completely the first time. And we want to make sure we can upgrade and optimize those as we learn more about that workload of that app. And containers really provide a modern and efficient approach to new apps and services that really let us get those three aspects of productivity moving forward. We want to have seamless integration of the infrastructure. And this is where, some of the new container solutions really, again, shine because we've integrated containers, the cloud or virtual management platforms, and they're seamlessly connected. So we don't have points of management. One of the old ways IT was done is it seemed every interface had its own management perspective or its own requirement for administrators. That's not the modern approach. Containers help create that single environment across infrastructure that really matters. And again, we can't say enough the flexibility to build it once and run it anywhere. Tweaking code to run on different platforms is just so 1995. And if you don't believe me about containers, there's some statistics that I think really show you how impressive the growth in container use has become. If we look at the container adoption study, 87% of enterprises are running containers today. So it may still be in DevOps, it may be somewhat limited, but the reality is the tide is coming in and it's not stopping for anybody. The thing that struck me about this same study is, okay, I understand people may test or they may use it in a limited fashion. But when you look at the companies using containers and 90% of them are using them in production, that's kind of what you need to know. Because, as someone who talks to a lot of CIOs and senior IT people, the one thing you can never mess up is production systems. That can't happen. And the fact that containers are being used with that kind of environment just shows you how important they become. 60% of these enterprises are running Kubernetes in production, and that's based on the Allied Market Research data. So we know where the winners are starting to come up. And Kubernetes is used by 77% of the firms using containers, according to System. So we're getting a sense that while there are options, Kubernetes is really the way the market is leaning. So given the importance of containers and so many of the benefits that they deliver to DevOps, the IT team, the organization at large, quite frankly, what should we look for? Well, there's 6 things I think have to be there. First, you want advanced cluster management. You want cluster services. The third one is one that I actually want to talk about a little bit, is a strong ecosystem of partners. What's very interesting is if we go back, and I hate to keep running into history, but we have to learn from it. The idea of closed or limited support platforms or vendor-specific platforms really was a major stifling of creativity. We couldn't do things because vendor A didn't have that solution, or we couldn't do them because we had to use a new technology that vendor B didn't support. One of the amazing things about the Red Hat Couchbase solution is it's part of this huge ecosystem of partners. And that really is essential because being able to find a specific tool, capability, functionality, or even a piece of code that's out there that you can reuse speeds the processes so much that it's just a huge benefit for meeting the speed of a digital business. And that strong ecosystem of partners really provides continuous and ongoing value for an organization that's trying to be aggressive and move things forward. The fourth one, again, I've said this, but it's worth repeating, is we need run anywhere capability. If your container platform has any limitations, somehow at some point you're going to run into them. Fifth is secured containers. We have to have security. One of the interesting things, as we've seen a number of new technologies come into the market, is they didn't always have the security that an enterprise or enterprise class company needed. We could all pick on public cloud services that had more holes than a Swiss cheese when they first came to market. Secured containers are an essential part of the container platform. We have to meet those requirements because we can do the greatest things in the world, but if the solution isn't secure, if it presents vulnerabilities, it's really no good. And in fact, there's probably no bigger proof point of this than the movement from what we call DevOps to DevSecOps, where security is becoming intrinsic in the process. And finally, a consistent platform from data center to the cloud, that basically it is a run anywhere, any platform, anytime kind of solution. Operators have become important, and they become an important part of really helping us use containers more effectively. And we're going to talk about those a lot, so I don't want to spend a ton of time on them. But 4 things that really are something to think about as you look at operators is they extend the functionality of containers. We can get more done. It reduces the demand for scarce human resources. This is a big one. It's very interesting that as we get new advances in the software infrastructure, there's always a lag in the number of capable professionals available to build things. So reducing that demand for more talent is important. It gives us more automation. As I've said, automation is the reality. We go back to the late 1990s, where we had the Space Odyssey and we had HAL, the smart computer. What was very interesting was we never saw that stop for a system update. We're not going to see any of that happen today. We're not going to wait for operators to intervene. We need to have more automation, and that's where the operator concept makes good sense. And we also see a wide range of use cases increases the attractiveness of operators, that it's not just 1 or 2 things operators can do. It's actually hundreds of thousands of things. And that, again, extends the value and the benefits of using containers. And now I'm going to back to you, Mike.
Okay, thank you, Aaron. So let's go to the next part of our presentation. We're going to talk a little bit about what Red Hat and Couchbase can do together in this area. So I'm going to introduce now Vijay to take us the next set of the slides.
Thank you, Mike. Happy to be here. Thanks, everyone, for joining this webinar. So as Aaron mentioned, he had positioned a lot of great points about why use a platform, why cloud, why be cloud native, why have native support. And I'm going to talk about those and then kind of provide you a contextual background from a Red Hat OpenShift container platform perspective. OpenShift 4.4 is the latest version. It was released just after the summit at the end of April this year. It runs on, under the hood, it has Kubernetes 1.17 as the orchestration engine underneath it. It also includes, from an installer provision infrastructure, it includes support for Red Hat's virtualization software. Azure and OpenStack, they do have support for it today. And there are a ton of other features from a development perspective that OpenShift 4.4 brought out with respect to serverless, say, for instance, service mesh, and then also OpenShift pipelines with Tecton. And you can also see it intrinsically ties itself with the storage platform, which is also called OpenShift Container Storage. There's a lot of work that goes on. And OpenShift, from the time it began, like when Red Hat started working with Google in the early days with respect to Kubernetes, the upstream Kubernetes, and bringing it as an enterprise platform to the organizations out there, we worked hand in hand with all the open source communities out there. And there's always work going on to make the product better, to serve our customers better, and provide more features that they want to have so that they can focus on building applications, running their business, and being successful at that. So OpenShift, we call it a smarter Kubernetes platform. The reason we say that is we have tried to streamline the installation and the upgrade experience with the platform itself. So if you had a chance to look at OpenShift 3, we used Ansible to install the platform, and you had to do at least a few things in sequence. But with OpenShift 4, we rewrote the whole thing. It's a paradigm shift in the way it installs and how it actually integrates with either your on-prem infrastructure provided, or whether it being a public cloud such as AWS, Azure, or GCP, and how you want to install it and manage it. And there's a tremendous amount of work that has happened in the past 2 years to be where we are with respect to OpenShift 4.4 today. And as part of that, CoreOS has become the default operating system from the master nodes perspective, and worker nodes where the container workloads actually run could either run RHEL CoreOS or Red Hat Enterprise Linux. The big thing about OpenShift is it provides you a consistent platform across either if you want to run it on your data center on bare metal hardware or virtualized hardware, or if you'd want to run it on the public clouds. Aaron rightfully pointed out that native support for cloud should exist as part of the platform, and he also touched upon portability. Those things are key from an infrastructure perspective. So Red Hat actually plays into a multi-cloud strategy or a hybrid cloud strategy, and you can seamlessly move workloads across your on-prem infrastructure or the public clouds. That's the capability OpenShift provides. And from a subscription model or a workability perspective, both for developers and operation folks or doing DevOps, it gives you a seamless or single pane of glass experience, if you will, to be able to do that. You do your applications, you deploy them, use a CI/CD pipelines, take it all the way from development to production in no time. That's a level of confidence and comfort that OpenShift provides to everybody involved, say, for instance, from a digital transformation perspective. This specific type talks about what capabilities that OpenShift provides for the developer folks and how it enhances productivity for them. I would like to point out that OpenShift, again, is the crown jewel of Red Hat's products, but again, it works synonymously with other products that Red Hat has. So it doesn't work in a silo. It tries to work with all the products that we have, which enables developers to do the best that they can to bring out the features as quickly as they can. OpenShift is not prescriptive. You can take your legacy applications, say for instance, if that's been written in Java 10 years ago, you can still do a lift and shift with minor changes to be able to leverage the platform, like take advantage of the features, say for instance, auto scaling, and figure out if it's the right platform for you and to use it long term. OpenShift also plays well to microservices or functions as a service. You can install service mesh to do a bunch of things. OpenShift also enables databases both from an RDBMS world and an NoSQL world to run, and that's how one of my peers is going to talk about Couchbase today. It provides you a great platform to play with and run your applications securely, and it helps you maintain them as you did on day one. OpenShift 4, this goes back to show how we have kind of expanded our horizon with supportability, with maintainability across, say, for instance, public clouds and the private cloud or on-prem infrastructure. Currently, we do have tie-ups with, or we partner with Amazon Web Services, Microsoft Azure, Google Cloud Platform, and also if you build out your private cloud on-prem with OpenStack, OpenShift can work with it. And it can install seamlessly, and it provides the same experience across everywhere. The difference between IPI and UPI is IPI, the installer takes care of everything, including provisioning your master and the worker nodes. With UPI, if you have pre-existing hardware and you want to leverage that, or if you have done a bunch of work on any of the public clouds, you can use those, customize them, and install OpenShift on top. We always strive to make it as easy as possible to bring up the cluster and be able to use it as quickly as possible as well. The way OpenShift is positioned across public clouds is that we work with all of the partners. Say, for instance, from an Azure perspective, we have something called as ARO, which is Azure Red Hat OpenShift, which is jointly managed by both Microsoft and Red Hat. The same thing with Google Cloud Platform. And we're the first to have an instance of OpenShift on AWS, which is part of their intrinsic ecosystem. We're really proud to say that, and AWS has come out with that announcement saying OpenShift will be part of their AWS CLI to begin with, and sooner rather than later you would be able to see it in AWS's console, where you go click, just like any other service you would like to order, or VPC or an EC2 instance, OpenShift would be available as well. So we're really proud of that, and we work tirelessly with our partners to be able to bring that experience to our customers. beginning 2014 till now, we've worked with customers and partners across the globe, and we have currently have about more than 1,700 plus customers on OpenShift container platform. And they're running it everywhere, meaning you can see that they're running it on AWS or Azure or Google, IBM Cloud, on-prem, virtualized hardware. They're doing that. And Aaron touched upon a very interesting point saying an ecosystem of partners, right? So OpenShift is not what it is just by itself. There's a tremendous amount of partners ecosystem that we have, varied products that they bring to the table, and all of those things can run on OpenShift because of our partners as well. They work hand in hand with us. They help us make the platform better, and by nature of it, bring their products to the platform, and it's a win-win for everybody, including the customer. So what workloads can we run on OpenShift? Anything that you can think of today. So from a database, being a relational database or NoSQL, or say, for instance, if you want to run big data workloads, that's possible. Monitoring and security products, that's available as part of our Red Hat Marketplace or the Operators Hub that we have as part of the OpenShift platform. DevOps, absolutely. DevSecOps, yes. And there's even talk about doing NoOps, right? So those things are all coming up. AI, ML workloads, they're all there. And from a storage perspective, we work with a lot of partners. We also have our own storage product called the OpenShift Container Storage. And anything and everything to do with middleware and messaging, all of those things are possible. And that's the beauty of OpenShift, that it works together with other products, with our partners' products, to be able to bring the goodness of everything together so that there's one platform for you to go to. You don't need to run multiple things on different hardwares to be able to do that. We don't prescribe as much as you want to do it. You can take leverage of the platform's features. It's all out there for you to be able to use. Aaron also mentioned about operators. Operators is a key thing from a product development perspective or a partner perspective. Say, for instance, if a partner wants to bring their product onto OpenShift, if they simply be able to give you a container image, what happens is that you would have to do the installation, you have to do the upgrades, you would have to maintain it, and you have to figure out what steps there are with respect to installing that particular or putting that particular container image onto the platform and how to manage and so on. Operators take all of that information away, or it kind of hides or encapsulates or abstracts that information from a user, where a user can get into the Operator Hub on the OpenShift container platform, do a single-click deployment of that particular operator, of that partner or any product team, and then be able to use that. Of course, you would have to supply certain information to be able to successfully install it, but those are the only things you need to worry about. The great thing about operators is it kind of gives you not just a feel-good installation part, but you can, it'll help you update the product, it'll help you maintain the product, and it could also do a bunch of other things with respect to backup and restore and so on. So it's really like you do have the technical expertise of that product owner built into that operator for that product itself. So you worry about how to use that product, that software, to be able to get a better experience, to be able to do your business as you wish you would want to do. With that being said, I would now like to pass it back to Mike. Thank you for the opportunity.
EJ, thank you very much. Appreciate the overview on Red Hat OpenShift. And now to learn a little bit more about one of your key partners, I'm going to turn it over to Evan to talk a little bit about Couchbase.
Thank you, Mike. Thank you, Vijay. Vijay, that was a great segue talking about the Operator SDK for us at Couchbase, because that's really the key feature of OpenShift, the key innovation over the last few years that has enabled us to work so well on Kubernetes and OpenShift. So I'm going to talk through why we're such a great fit for OpenShift and why and how we can do multi-cloud and hybrid cloud with Couchbase on OpenShift. But first, I want to give a quick overview about Couchbase. Similar to Kubernetes, we had open source foundations at Google and Facebook, in this case, a project called Memcache. The Memcache founders and the CouchDB founders came together. The primary committers to those open source projects came together to create a company called Couchbase. So one thing that Memcache had was being used for back then was web scale workloads at Google and Facebook as their primary cache, and it's still used today for that. So Couchbase is a data platform. It's more than just a document NoSQL database because there's lots of other features built into this that we need to talk through. So the first one being the managed cache, which I mentioned, which has been cached. Second is the key value store, and this also supports other types of primitives besides just documents. So Boolean, strings, ints, and arrays, things that you might typically think of for using Redis for. And then also the document database, which is where we primarily store JSON documents. We also have a mobile solution and a product called Sync Gateway, which enables online and offline support for mobile devices. And we have lots of customers using that in the field. And also we have by far the strongest SQL support of any NoSQL database out there through our N1QL query language. Full text search is another service that's available, and it comes with Enterprise Couchbase, and it gives you Lucene-like full text search over your documents. And then finally, the eventing service, which is sort of programmable triggers in JavaScript that allow you to really extend the functionality of Couchbase as data is coming in. And then also the analytics service, which is the newest service we've added, which is ideal for large complex queries. It's a multi-parallel processing engine for doing ad hoc queries on large amounts of data. So it works with things like Tableau and other BI tools. It's great for doing analytics on your NoSQL documents. So really quick, I wanted to talk through some of the customers. So we play in every major vertical. We're being used at scale at all of these customers. And also there's a lot of overlap here where we focus on large enterprises and have a lot of deployments there. So does OpenShift. There's a lot of overlap with OpenShift. That's why one of the reasons the partnership has been successful is there's so much common use cases, common customers where they're using OpenShift and they're looking to modernize workloads and leverage Couchbase for that. Here's a little more detail. We often in the past have called ourselves an engagement database or systems of engagement. So we do really well in situations where we are close to the end user operations. So you typically see us use as a session store, a cache, a user profile store initially as the first use case. And then as customers see how easy Couchbase is to manage, how easy it is to scale, they will often expand into other use cases and start using it for even source of truth, system of record use cases, transactions. And again, we span all the major verticals and lots of different use cases within those. Okay, so I wanted to talk about how we fit the Kubernetes paradigm specifically. So if you think of relational databases, traditional old guard databases, they're more monolithic in their architecture. So when you talk about a system or a cloud native platform like Kubernetes or OpenShift, you're talking about scaling horizontally and not vertically. You're talking about having to shard and things like that with your data. It can get very, very complex. So Couchbase was engineered and architected from the very beginning to work on scale-out architectures, and also has master-master architecture. So there's no single point of failure. And we also do sharding automatically, which is another major pain point of even some of the other NoSQL databases that are out there. So it's a huge benefit of Couchbase. So multi-dimensional scaling, though, is probably the key feature that allows us to fit the paradigm so well. What that means is that every service, the services I showed you in the first slide about Couchbase, is essentially its own microservice, which can be scaled independently. And this is what an architecture could look like potentially just on a standalone Couchbase cluster. So here's a couple of different topologies that you could imagine on a containerized Couchbase deployment. So we run very well in containers. We've supported running Couchbase in containers for a very long time. So the first diagram we have, basically running index, query, and data on all 8 containers that are in this particular cluster. And the second cluster, we're showing how you could do workload isolation and separate them so that you have data service running on containers 5 through 9, index service on 3 and 4, and the query service on 1 and 2. So what you can see here is that you can scale your Couchbase deployment with your workload. So, and we see this with our customers. They're all over the place in terms of what their topology looks like, because they're able to scale each service independently up and down depending on the workloads that they're trying to support. So you can imagine like a heavy full text search index might have a couple of full text search nodes added in here. or a service that's doing a lot of analytics would have an analytics service added in here. So again, you can scale them each independently, so you don't have to worry about unused resources. It makes capacity planning a lot easier. Here's an example of what it could look like on an OpenShift cluster, where we have a similar sort of topology running on an OpenShift cluster. The other thing I'll point out here is persistent volumes, for the persistent storage there. So one of the key features that enables running stateful workloads on Kubernetes over the last couple of years, again, is persistent volumes. And persistent volumes, with Couchbase in particular, give us the ability with our operator to, in the event of a cluster failure where we lose a pod or a node, we can take that persistent volume and reattach it to the new node when it comes online, which makes the rebalancing process a lot easier and speeds it up substantially. Another major feature of Couchbase that helps us enable multi-cloud and hybrid cloud workloads is XDCR, so cross data center replication. This is a very mature feature in Couchbase. It's not something that just got bolted on so we can make this claim. It's something that's been in Couchbase for a very long time. It has a lot of advanced functionality. So it supports different topologies. You can do directional, bidirectional, and ring topologies with the replication of your data geographically. Obviously, this is eventually consistent if you're replicating data this way. We also support advanced filtering so that if there's particular data you don't want to replicate geographically, you can do that as well with XDCR. So, and I have to stress that this is also a very highly secure feature. We support TLS with our operator as well, so you can add custom certificates to secure data in flight as it's going across your networks, across your clouds. So I just wanted to stress that as well.
So Vijay mentioned the operator framework. And Couchbase has the most mature operator in the market today, especially for databases. We were working with the Core OS team early on in the development of the operator framework before Red Hat acquired Core OS. And we recently were featured in the blog on Red Hat about our operator maturity. So the operator is truly the feature, the Couchbase operator in particular, is truly the feature that allows us to shine on OpenShift. Some of the features it provides are cluster lifecycle management. So this includes provisioning and deployment, cluster scaling. You can scale up or down on demand with the operator. You can upgrade the cluster. It performs rolling upgrades for you, with the operator, so that you can easily do rolling upgrades. Again, that's something that's usually very painful for an operations team to do manually or with other automation tools. The operator will handle that for you. And cluster auto recovery. So this is a big one in the event that an availability zone goes down or you lose a Couchbase node for some reason. The cluster knows how to spin up a new node, tether it to the cluster, and even rebalance the data for you. And then going a little deeper into the configuration, it supports persistent volumes. This really comes in handy during cluster auto recovery. We can take a persistent volume that's been detached from a pod that crashed and reattach it to the new pod when it comes up and pick up where it left off, which greatly speeds up the time it takes to rebalance. Server groups is a critical feature. It allows us to distribute the Couchbase cluster evenly across the availability zones that your OpenShift cluster runs on. Cross data center replication, as I mentioned before, is enabled through the operator as well. TLS and certificate rotation for security, user and group management for authentication and authorization. So again, another feature that's enabled through the operator config. I'll show what that looks like in a minute for some of these. Backup and restore, and then finally Prometheus monitoring. It comes with a Prometheus exporter that can connect the Couchbase metrics to your single pane of glass monitoring system to give you visibility into the whole stack. So if you take all these things together, you're talking about a significant amount of manual effort that's typically involved with managing all of these. And the operator automates all of that, which greatly increases your agility and flexibility when you're developing on Couchbase. So with that, I'm going to jump over to the demo. I went ahead and already installed the Couchbase operator, but I'm going to show you what the process looks like. That's step one, installing the Couchbase operator. Before you can deploy a Couchbase cluster and for any buckets or anything like that, you need to install the operator. So the easiest way to do that is through the operator hub. So on the left-hand navigation here, you'll see operators, operator hub. Click on operator hub. You'll see the Couchbase operator. Click on it. There'll be a button to install it. I've already installed it to speed this demo up a little bit. So once you've installed it, it'll show up under installed operators. You can see that here. and you can click on it, and it shows you all the different types of objects you can create through the operator. So in this case, you've got Couchbase clusters, buckets, users, groups, role bindings, and backups that we can create through here. Let's go ahead and take a look at what this looks like. I'm going to show you what our deployment looks like in a YAML file, as opposed to looking at the YAML through the web UI. So you can see there's 3 objects in this YAML file, and the way I deployed this was first deploy the operator, like I showed in a couple of clicks through the OpenShift UI. Then you take a YAML file like this. In this case, I have my secret is the first object. The second object is my Couchbase bucket called tweets. And the third object is the cluster definition. This is a very simple, sort of bare bones Couchbase cluster. Just for demonstration purposes, because I'm trying to keep this simple, you can see we have 3 nodes, and we're going to run the data index and query services on all 3 of those nodes. We're not going to use multidimensional scaling here and break them out into separate server groups, which we could do. This is an arbitrary name. You could name this anything you want. You can create multiple of them. So you could group the services together and deploy it that way. Another thing that it will do is it will automatically deploy them across availability zones. So if you're on AWS or a cloud provider that has separate availability zones, you can benefit from the redundancy and high availability that comes from that in the event that an availability zone was ever go down. So anyway, here's a simple configuration. And I deployed this in the command line by just doing this. OC-F create Couchbase cluster.yaml. So this is what the command would look like. It's a directory here and then to the YAML, and it'll do the rest for you. The end result is you get a Couchbase cluster like I just showed you in the YAML, and you get all those objects running here on your OpenShift cluster. If you look at our pods under Workloads, you can see we've got 3 Couchbase pods. Couchbase example 0000 through 0002. So we have 3 nodes like we asked for. Here's the operator pod. There's also something called the Twitter streamer here. I ran this so that I can get some sample data loading into Couchbase, just so we have a data set to show. This is a real-time data set that's constantly being streamed in, so we can see how the Couchbase cluster performs during some of the scenarios we'll run it through. One thing we haven't done is access the Couchbase admin UI. I'd like to do that for the demo. So let's go ahead and go to networking routes, create route. We'll call this the CB admin UI. We will select the CB example UI service. I named my Couchbase cluster CB example. That's why you see CB example prefixed under all the services, before all the services. And then the port is the standard Couchbase port, 8091. Also give us a route to see if we can access the Couchbase cluster. And there we go. So if we go to buckets, you can see we've got a bucket called tweets. There's already 100,000 documents in here. And I'm still logged in, so I must have had a cookie on my browser from my login from last time I logged in, so that's good. Didn't have to log in. You can see what we're ingesting. They're just pretty simple Twitter documents. And if we go to servers, you can see we have 3 Couchbase servers, 3 Couchbase nodes running, and it tells us the services they're running, data, query, and index. And they're all in group 1 because we're doing this in a single availability zone. All right, so let's go ahead and run this through a couple of scenarios. So the first one I want to do is actually try to scale the cluster. So what I'm going to do is change my number of servers from 3 to 4. I'm going to increment by 1 and see what happens. Let's go ahead and run this. We'll do OC-F replace our YAML. Oops, I got that backwards, sorry. This should run. Okay, it says it was replaced. So let's go ahead and see what happens. Refreshing Couchbase. On the OpenShift side, you can see you already have a new pod come up already. So CB example 0003 has come up. and there's a rebalance kicking off. So the data that we'd ingested already, those 100,000 plus Twitter documents, are now getting rebalanced across the cluster. And let's go ahead and look at our what's going on in the OpenShift side as well. We can go to pods. So you can see we have a fourth pod now, 0003 is running right here. And so that happened really fast. So we brought up a new pod, brought it online, tethered it to our cluster so that the other nodes are aware of it, and now it's rebalancing the data. This will be done in just a second. That's awesome. Okay, so the next test I'll do really quick is to just simulate a failure. So we can imagine for a second that this was deployed in multiple availability zones, or maybe it's not, but maybe one of our worker nodes went down, right? And a Couchbase pod is running on one of those OpenShift worker nodes. What's going to happen? So let's go ahead and delete one of our Couchbase pods and see what happens. So I'll just grab a random one from the list here. Let's take CB example 002. Just want the first part of this. And we'll do OC delete pod CB example 0002. Hit enter. Okay, the pod's been deleted. So immediately the Couchbase cluster recognizes that the pod is offline. Now, there's always going to be network partitions and other scenarios that happen in any distributed system. So it's not going to instantly fail over to and bring up a new pod online for us. It's going to wait a little while to make sure that this node is in fact gone. That's a threshold that's configurable in the YAML. But once it does realize that that pod is gone, it will bring up a replacement pod. And so what we'll see is we'll see a new pod get created here under our pods on this project. And then after that comes online, we'll see that pod get added to the cluster, just like when we scaled the cluster. And so if we jump over to buckets, one thing you'll notice is that we still have data flowing in, and we're not losing any data, which is also important. Because one of the things also with this is I set up the bucket to have replicas. So if we look at our bucket here, you can see the tweets bucket has 2 replicas. So what this basically does is it guarantees that if we lose one of our Couchbase nodes, we still have copies. And actually, we can lose 2 because we set replicas to 2. So at some point soon, okay, there it is. Oh no, it's not there yet. So we'll wait here. Let me double check what that threshold is set to. 120 seconds. So it'll take 2 minutes before it decides to add a new pod and bring us whole again. So should be coming up very soon. And I apologize because normally before demos, I will turn that number down just so this happens a little quicker. Forgot to do that this time, so. There it is. Okay, so now CB example 004 has come online. It's already running. It's not in a ready state yet. But as soon as we see that ready, we should see it start to come online and rebalance. And there it is. So now it is rebalancing. And we're up to 121,000 tweets. So that replica that was potentially down for a minute or two is back online. And the data here rebalance and we'll be whole again without losing any data. We'll be back right back where we left off, plus any delta. So this is really a critical feature of the operator. When you talk about architecting systems for reliability and resilience and for efficiency, where your ops team is not getting pinged at 3 o'clock in the morning when something like this happens, because that's always when things like this happen, right? You can trust that the Couchbase operator is going to heal your cluster for you as long as it has the compute resources available to it, right? So that's really the major value add, one of the major value adds. We're out of time. Otherwise, I would show you the cluster upgrade, rolling upgrade feature. The process is very similar. We would just go in here and change the image. from 6.5 to, it could be even a downgrade if we wanted to, but to another version similar to before, and submit this YAML. What you would see happen is the same thing you'd see it done as a rolling upgrade. So each one of these servers would come one by one, a new one would come online. So we'd have 5 nodes temporarily. It would copy data over to that new node, then bring one of the old ones down, and then repeat that process until all 4 are running the newest version that you asked for. That's how rolling upgrades work. So that we're out of time, but thank you so much for listening and watching the demo and our presentation today. And I'm looking forward to hopefully talking to you in the future about Couchbase Autonomous Operator. Thank you.
Great. Thank you, Evan. Thanks to our presenters for sharing their insights. And we do want to take just a couple of minutes to take a few questions from our audience. Vijay, we're going to start with you with the first question. Our audience member wants to know, is Operator Framework free to use?
Yes, it absolutely is. Just like how Red Hat develops all of its other products, it's based on an upstream version, and anyone interested in developing an operator can absolutely get to that and use it.
Excellent. Evan, our next question is for you. How is containerized multidimensional scaling managed to ensure that all my workloads perform well?
So scaling with our operator is on demand. So this does not scale automatically. One of the things the operator also provides is a Prometheus exporter. So if you're monitoring your OpenShift cluster, in this case with Prometheus, with Grafana as probably the front end, you can set up the Prometheus exporter to give you very detailed metrics on everything that's happening with your Couchbase cluster. And so if you're seeing that a particular service is not keeping up with your SLAs, it makes it easy to go into the operator and simply increase the number of, let's say, the query service is being overwhelmed. You can go in on demand and just increment the count of query service nodes until you get to a place where the latency is meeting your SLA, as an example. So it's also on-demand scaling is supported with the operator. And I showed that in the demo when we went in and incremented the count of Couchbase nodes. You can do the same thing at the service level.
Very good. Vijay, we come back to you for our next question. How does Red Hat certify operators developed by vendors?
Yes, that's a great question. So typically partners, when they work with Red Hat and they would want to certify our products, we've developed an extensive guide which walks them through the prerequisites and the steps involved to first create an operator and then to get it certified. The simplest of those requirements is to be able to develop their products on top of UBI, which is called Universal Base Image, and to be able to extend that and put their applications or products on top of it. And there's quite an extensive documentation on it. And then once they're done that, they upload it, we roll it into those tests. Once they pass the test, they get into the catalog.redhat.com, which is the official certified operator portal that is provided by Red Hat.
Great. Time for one more question, and Evan, we'll come back to you for this one. How do I combine my data sovereignty rules with cloud-native data management to be certain I'm letting the right data move?
A great question. So I mentioned with the cross-data center replication that we support advanced filtering. So if you could imagine, say that you've got a data center with a Couchbase cluster in Europe that's collecting data that needs to be GDPR compliant, but there's certain other data that you want to replicate geographically over to the United States, you can configure filtering with cross-data center replication so the only data that's safe to replicate goes across to your US cluster. So we support all that with the filtering capability in XDCR. It's very sophisticated, the rules that you can create. So it's very flexible in that regard. It gives you the control over where the data goes geographically.
Okay, great. So that does conclude our program for today. I want to take a moment to thank Aaron, Vijay, and Evan for their presentations. We appreciate them sharing their insights with you all. Once again, we want to acknowledge and thank Red Hat and Couchbase for sponsoring this program. We really appreciate your support. And last but not least, we want to thank all of you who attended this program. Thank you very much for joining us. On behalf of TechTarget, Couchbase, and Red Hat, thanks for joining us, everybody. We hope you have a great day.